All right, so we're here talking about going over some free response questions from chi-squared. So let's go to a new listen spreadsheet. So new document, listen spreadsheet. And what should we put for the first column? Moose. We've got 25, 22, 30, 40, and 117. What do you want to use for the second column? Expected moose. How am I going to calculate the expected moose? Say it again? -1? No, that's the degrees of freedom if you're talking about for this problem. The total number of moose.
Over 100.
No. Total number of moose times what? Very good. Times the proportion of the total acreage. So how many moose are there? No, that's what I want. How many total moose are there? Did I write down 117 in a column? I might be. Let's erase that. Okay. So equals 117 times 0.34. So there's my expected number in habitat 1. So in habitat 1, did I see more or less moose than I thought I would? I saw less. I saw 25 moose. Look, Marcelo, but I expected to see 40. I expected to see 40. I only saw 25. Okay? Let's look at the next one. Equals 117 times 0.101. So I expect to see about 12. How many did I see in habitat 2? I saw more. I saw about 10 more than I thought I would. Okay, interesting. Habitat 3.104. I only thought I'd see about 12, and I saw 30. That's way more than I thought I would see. And then finally, the last one, which had the most amount of acreage. I expected to see, well, it has the most room, right? The most acreage. I expected to see about 53, and I only saw 40, so I thought I'd see more there. All right? Are there any questions so far about setting up these columns? You could have done this like separately, like in just a calculator page, and then typed in the expected value. That's fine too. No questions? Everybody good? Okay. So now let's go ahead and run the chi-squared test. Which one did we say we were going to run for this one? So doc, insert, calculator, doc, insert, calculator, menu. Everything okay? Stats. Suzette, everything okay?
Yeah, my computer had a...
Okay. Chi-squared goodness of fit is number 7. What is our observed list? Moose. Our expected list. Expected moose. And then degrees of freedom. Marcel, you were asking about this. This is the number of categories minus 1. How many habitats were there? How many habitats were there? 4. So 4 minus 1 is 3. I know you're thinking sample size, but we're talking about the 117 is just all the moose. That's not a sample. It's just how many moose we see. So it's going to be 3. Degrees of freedom 3. Think back to our M&M's example. We did the number of colors minus 1. Okay? All right, hit OK. Now, you should see chi-squared is very large, almost 44. And look at that p-value. I know it's weird because it's actually in scientific notation. That's actually 0.0000000. I lost track. 0.1756889. So it's really tiny. So the p-value is basically 0. Now let's just say that you knew chi-squared, but you didn't know the p-value. All right. Go to menu, just for fun. Menu. Statistics. Distributions. And do you guys see number 8 where it says chi-squared CDF? We've never used that, but I want to make sure you see this before tomorrow. There might be a question on it. Maybe. And the lower bound, go ahead, Margot, is chi-squared CDF. Chi-squared CDF. When you have chi-squared and you're trying to find the p-value. So like they'll give you chi-squared and say, hey, what's the p-value? We've used this before, Margot, when we did with z-scores. We used normal CDF. And then with t values, we did t-CDF. So it's the same idea. It's just a new model, chi-squared. So the lower bound will always be your chi-squared. I'm going to repeat that. Your lower bound will always be your chi-squared, which in this case was like, what, 43 point, I don't know, a lot, 86. Upper bound is infinity. Degrees of freedom was 3. And I know it's not exactly the same because I didn't put exactly the same chi-squared number. But you see how to do that? Use chi-squared CDF. So review this video before tomorrow if you want to make sure you get that question right tomorrow. Say it again, Mara? Okay. Okay. So what conclusion are we going to make about the moose? What conclusion did you guys make about the moose? Oh, there's definitely enough evidence, Jacob. The p-value is nothing. The p-value is 0. Really, Marcelo? The p-value is basically 0, which means you definitely have enough evidence to say, you know what? These proportions you gave me, my moose, my observed moose, do not fit the proportions you gave me. They're not consistent. My moose that I observed are not consistent with this proportion of acreage. So there's something else going on. And it's just because they want to get away from the burned area. Which makes sense, right? Animals don't want to be around things that are not growing. Okay. Okay, if you flip it over, if you guys flip it over real quick, I got a few more minutes. Listen, shh. If you flip it over to the next question from 2016, did anybody get a chance to look at part B? All right, so sometimes they'll ask you, after you make a conclusion, to then write a sentence based on what you saw. All right, and what was in the data in that table. So just that part B, if you haven't looked at it, take a look at it. I sent in the email to you just now. I sent you the answer key for part B. Where's 2016? Is it? Yeah. So make sure you take a look at this so you can see how to answer part B. All right, there it is right there, part B. So I want you to make sure you take a look at that. All right? Excellent.